Right, we'll just make sure this duster's on here. No doubt been polishing organ bits. So I've got Uniden 200 here. It's absolutely immaculate. I've got the 4 capacitors out, which we're going to need before powering it up. End users. This is from an end user. It's the second time he's had a repair with us. As you know, since COVID, we've done 1 or 2 end users as well as the usual trade customers. Please don't leave accessories. It got the mounting bracket, the thumb screws, and now it's got this as well. Because they're so easily lost, we're just not geared up to doing things like this. So, in fact, I'm not going to put this back on because it does mar the finish of the set. I'm going to go straight away and put this back in his box. Edited out those 2 minutes. Put the soldering iron on because we're going to need it. You notice that they're shiny screws, not the usual black ones on these sets. So for the last 15 years, every time that we've seen a radio using this Uniden chassis, that's the Uniden's, the audio line, and the realistic sets. So that includes the base stations. So that's the Uniden 100, 200, and 300. Audio line 340, 341, and 345, isn't it? This isn't the 342, which is the remote set, though. I'm not sure. A different chassis, but maybe just as troublesome. Then the realistic 2000 and 2001, no other realistic models. Right, we'll put those on one side. I don't want to brush those on the floor, we haven't got spares. Pop the speaker off. And put that on a piece of polystyrene we have up there. So we need to change these 2 470 microfarad capacitors and these 2 220 microfarad capacitors. I'm not powering them up with this setup with those in. You've got the phase lock loop chip, which is irreplaceable. Yeah, there's a firm in Brazil said if I buy 100 at £29 each, you know, yeah. Well, I tell you what, if they were £29 out of my door, I wouldn't be selling many, 2 a year? You know, people aren't going to pay that for a chip which, yeah, it was always like 12 to 16 pounds, but it's too much money to bring back to life a 1981 set, and it's usually only killed by the people who've done the silly modifications. So, there we go. But they do. Right, so I'll take those out. As did I say, the 220 microfarad ones there. It's on the 5-volt rail to the phase lock loop chip. Classic thing is the display doesn't work, and it's because the 5-volt rail is being shorted out. So you've got a 220 microfarad there, which is another part of its internal power supply. Then there's 2 there, which are 470 microfarads. So if those start to fail, we've got the MB3712 audio IMC, which can be expensive. Again, that you could easily have paid £10 plus for that even back at the time. So I'll tell you what, I've shown this time and time again. We'll pause the video and we'll come back to it when I've changed those capacitors. Okay, so that's done. So 1, 2, 3, 4. I'll test what's come out. Now that one, the 220 microfarad which came out there, had been changed, but someone's changed it for exactly the same type. as if they'd taken it off another set with this chassis, which is a silly thing to do. It's like putting the rusty old door on off a scrap car on to your own car with a rusty old door. Even if these work now, they won't work shortly. We learnt this the hard way by sending a set back. That works right now, but it's starting to get high. We sent a set back and it was back a week later because it failed. And then it looks like we've not done something right. So, you know, you've just got to do a blanket job on what you know will fail. Slightly high as well. This is what happens. They start to go high, but they become leaky. We've got that nasty glue off this as well. It doesn't matter so much in the stages like this on the radio, but it would, that's high. It would matter in small signal areas. And it certainly would matter if you're dealing with valve equipment. Wow, that's well out. Yeah, so that really is on the brink. Good. Well, in that case, we will connect this up. So we'll plug in the test equipment. Now I've done that, it should just be a 25-minute tune-up. Now you can't set the frequency on these sets, so what you get's what you get. So as long as it's within tolerance, that's how it is. When they brought the CPT version out of this with the Uniden 400, at least it was frequency adjustable. But that might have been in the rules of MPT 1333 and not in the rules of MPT 1320, which was the Home Office at the time legislation that governed the specification. What am I actually looking for? I'm just making sure it's not got any silly filters. Yeah, so it's fine. It's as it should be. Right, the microphone. Factory original microphone. Bit bassy with this mic. You may be best off. It's absolutely great having the factory original mic, but you may be best off using a new microphone. In fact, I think we'll do some initial tests using that mic. Make sure the deviation is correct, and then we'll do everything else with our brand new test mic. There we are. That says Uniden on it. I'll swap them over when we do the deviation. So I'm going to have to get the service manual out. We're using the realistic service manual because the realistic service manual is superb, and I never saw a Uniden service manual. I wrote to them, they didn't answer. Never saw an audio line service manual. I think they wrote back and said they didn't do one. The remote one, the 342 Trader, Wireless and Electrical Trading did a supplement. They were still going in those days, so we do use that, which is okay. So it's supposed to be at least 3.4 watts. And the sensitivity, because these are nothing like as sensitive as the Cybernet sets, and so they got, I think that's why they got a better reputation for bleed over, because they were less sensitive. It's supposed to be better than 1.2 amps. And when we get to sensitivity, it's supposed to be 1 microvolt for 10 dB synapse, which is exactly what the Moonraker Micro specification was yesterday, and it well exceeded it, 0.28 microvolts. I think it was 0.28, it's still on the clipboard. 0.29, my memory. So we'll start this off. It's 2nd of July, I do know that. It's a Sunday, and I've done my church services. Uniden Uniace 200, we'll come to the serial number later. Two times 220 microfarad, 2 times 470 microfarads, and then Nikon capacitors I've fitted. Right, switch on. I will just start at 9 volts because I don't know what the set is doing. It's powered up at 9 volts, showing 160 milliamps. We'll go to 13.8 volts. It's now drawing 200 milliamps. That's just precautionary. I'll tell you what, we'll plug the PA speaker in. Take that stereo adapter off, which we had to put on for yesterday, and plug in the test equipment to the other one. So it's come on channel 20. It's nice to see that the high-low brightness works on the meter lamp and the display, the LED display. Switch to PA. Let's see what happens. So is it on mic gain? Probably is. Testing 1 2, testing 1 2 3 4. Rather than volume 1 2. Yes, it is. It's just on mic gain. So that's another box we can tick off. Also proves the mic works. PA, mic. Oh, meter lamp. It's back to CB. So if I can find the RF gain, turn that to full, mic gain to full, put picture in picture on. All I need to do, before I start playing with that, I need to do the VCO. Now, it doesn't look like it's been fiddled with. So, if it's only minutely out, I won't bother. So it's done on channel 40 on this, initially. So there we are, channel 40. Get our little £16.99 multimeter out. Can't remember whether it's a floating chassis or not. We'll soon find out putting the probe between there and there. It's a negative earth chassis, so we can poke the other prod in a hole somewhere. And we're looking for test point 1, and test point 1 is at the top of a resistor somewhere. This is the trouble, unless you're doing these every week. So the 2000 is equivalent to this model. 2001 is the smaller one. Test point 1. See test point 2. One top of resistor 52, which is that one. It's actually the one I thought it was. So in transmit, we should have 3.5 volts. plus or minus 0.1, so that is too high. .5. Okay, so on receive we're not given a voltage, but they want you to adjust L18, which is that one. Test point 2, I think it's there. They basically want you to test the maximum on the oscilloscope, and we've done that time and time again, but then you have to readjust it later when you come to tune the receiver. So we're going to skip that stage, not because I'm trying to skip stages, but simply because this radio is already going to be working, isn't it? So it's not like we're setting it up from fresh or after a major realignment because of some huge malfunction and a golden screwdriver expert. So it's already going to be working. So that is only going to need to be maxed out with an oscilloscope testing on test point 2 if you've got no receive. Now they do receiver first, which I think is topsy-turvy. We do transmit first. Okay, so we've done that. Let's see what it's doing on transmit. So I'll make a note, because there isn't a voltage as such for receive, so it should be 3.5. I think it was 3.9, wasn't it? We've done that. Oh, I'm in the wrong box now. Can't do anything. .1 watt on channel 20. 3 watts on channel 40. 3.1 watts on channel 1. Low power, back to channel 20. Should be 400 milliwatts. Let's go to the lower scale. Have I pressed the wrong button or something? Yeah. Press tone. He's 300 milliwatts. I don't know whether it's adjustable on this. Transmit current. 802. You can tell it's not doing full power because it's under an amp. We'll come back to frequency because as I can't adjust it anyway, and the test gear's only been on 15 minutes. So it's just make sure we're not doing anything wrong. It's L16 and then 15. 16, 15, 14, 13, 12 and 10. And it's 10, that final one that we do the power with to get the 4 watts. Now on a Cybernet set, you've got kind of a similar arrangement apart from all the screening. But the coil which is slightly offset is part of the receiver. And so you often get Cybernet sets where somebody's twiddled that and the receiver's now a bit 10-1 because they thought it was part of the transmitter. Okay, so we want to bring that up a bit. That's already peak. That's already peak. That's already peak. That's already peak. That was pretty close. And hopefully we can trim it with this. Needs a bit more soldering iron action. There we go, 4 watts. So now, the other channels, channel 40 is 4 watts. Channel 1, 3.95. And go back to channel 20. And let's go on low power. It's now 280 milliwatts, so I need to adjust that. Hopefully we can, it's labelled instead of me looking at the manual. It is. $400 milliwatts. And now power consumption is still very good at 902. We'll just do the power meter while we're at it. So it should be the centre of the red zone, and it is the centre of the red zone. So I don't need to touch that. RF meter is RT3 there, and it says RFM for RF meter. So that's good. I'll be able to knock him a penny off. We'll look at frequency. 2779064. I'll write that down at the end. It's not off frequency, but I'd like it to be 085. But then yesterday's brand new Moonraker micro was 083, so it's not out. Next, deviation. If this is playing ball today. We'll test it with the machine behind me as well. Just tune it in. Wallow, wallow, wallow. It's 3.2 it says. I actually believe it. I'm going to use our mic. Wow, it's 3.8. So that has had the golden screwdriver. So bring that down. Because my test set's working properly today, we'll do it with the oscillator. We'll do it with the mic that is actually connected as well. You know that, it was at full. Wallow. It's now too low. Wallow. Now, I'll test it with the test set behind me. That's telling me 2.2 to 2.5, which is where it should be. But I can't trust it because it's playing up. So we'll just connect to the 2828 I set behind me. You know, I'm getting daft by the minute. I've unplugged the one from the back of the radio. I need to unplug the N one from the test instrument. Wallow. Still too high. Wallow. It's not like AM where more modulation will get you out better. Because it's the width. It's adjusting the width of the signal. So of course if it's too narrow it will sound quiet. But if it's too loud, it doesn't sound louder. It just chops the edges off on a set with decent filtering. It only sounds louder on a Fidelity 1000. And then you are causing bleed over. So it was probably about 4.5 to be honest, not 3.8 I wrote down. Wallow. Yeah, it's reading about 1.5 on this one because the machine's light. So it's now 2.2 to 2.5 kilohertz. So we'll do the frequency right at the end. So now we'll go over to receive. CB27 put that on the frequency counter. We'll set this a bit low, so we're not setting up the receiver lopsided. So I'll put it 79100. It's probably about where it is. It actually sounds... Oh, it sounds a bit better when I put it in the right mode. So before we adjust it, let's take some readings. So for 12 dB, we've actually got 0.6, which is good for a Uniden. 10 dB, got 0.52. So that's where the manual says better than 1. If it'll do 20, it is 1.55. Squelch. It's 2.5 millivolts. And the threshold that one's cleaning. Switch the signal generator back on. And it's a not very sensitive 2.4 microvolts. Kind of amount that would cause me not to hear him round scratchy corner. And at the moment, let's see where the meter is. So 100 microvolts should be 100. It's 2. It should be there. So it's 55 microvolts. So it's reading a bit too generous. Like it matters. Okay, we're going to start with the detector. I'll take the light off. We'll stick the camera onto the oscilloscope. Or just the detector. So this is the... You can end up with 3 different peaks as well, so it's something else to watch. But because this set's already a working set, it's not that far out, of course. It's not going to be on the wrong peak. So I think it's this one. It is. It was absolutely spot on. Good. So we'll go back to the service man just to make sure we're doing these in the right order. I think we start at that end. So it's L654321. So they have you do it the other way around. It's not the right way round. So we need to do 1, 2, 3, 4, 5, 6. We're not starting with the IF, we're starting with the front end. So 1, 2, 3, 4, 5, 6. They have you do the detector at the end, we do it at the beginning. Right, we'll turn the oscilloscope off. Here we go. So we want to attenuate the signal. So we're not saturating the receiver. That was spot on. That was spot on. That was spot on. I'd like to think we've gained something on that one. Put the biggest signal on for this. That was slightly out. Smaller signal for that. There we go. That's it. Right, I'll stick this now on the attenuator and we'll see whether we've actually got an improvement. So 1, and we're looking here on the top scale, so it's 4.6 and a bit. We'll call it 4.7. Yeah, we'll definitely call it 4.7. Or 0.47. So 12 dB is now 0.47 microvolts. 10 dB, which is what the manual said needed to be under 1, is 4.3, 0.43. And have we brought up 100 mic? You know what? It's just doing 1 microvolt. Let's change scales. It's 1.05. 1.05 microvolts. So now we'll recheck the squelch. Now it might have automatically come right if we've fiddled with the IF. On the other hand, it hasn't. Oh, this must have been golden screwdriver, this bit. But the receiver, pretty well spot on. You don't often see them as sensitive as this. A lot of them are hanging around that 1 microvolt area. So this isn't actually deafer than most cybernets. It's about exactly the same as most cybernets. And then we've had 1 or 2 outstanding cybernets doing 0.25, usually the 5 stars. And the Oscar 1 with its tiny little meter, it's not the Rotels that tend to do them, or the Yorks that do the really good sensitivity. It's some of the more unusual ones. And I said there used to be a time when you could buy a 5 star for a tenner, when a Rotel would have cost you 40 quid. But, oh, well, it's Barnaturn, it'll be no good. It's not the case. They just bought things like Amstrad just bought in a Cybernet set. It wasn't, they didn't make it. So, we're looking for squelch. Here we are. It's exactly where I want it. So now we'll do the opposite and we'll set the threshold. It'd be unfair to give it an exact thingy yet. I'll just turn the set off. We'll just spray that control. At least it's not a closed construction one. I'm not doing them all willy-nilly. I just don't want to spray out the lubricant. Waggle that around a bit. Switch it back on. That's what we want. Perfect. Right. Signal joins are back on. No, this isn't nice at all. Let's give it another go. Definitely threshold. That's it. It's 1 microvolt. You've got to be spot on that squelch control. But I was the first time round as well. So it's now 100 microvolts and 1 microvolt. The switches are okay. The sockets are okay. The potentiometers are now okay. The frequency. It's going to come up from this because we haven't had it on as long as I would. Let's go over to that. If I came back to this in 2 hours, it's going to be above 0.85, I'm sure. But we'll jot it down, 27799067. The only way to change that is to change the reference crystal. And every time I buy cheap reference crystals, I get one in a pack of 10 that works. So I think you're better off with the devil you know than the devil you don't know. Good, well I'm sure that's going to work really nicely. I think we've covered everything. Oh, RF meter. We haven't covered that. So now, with 100 microfarads on the signal generator, look at that, it's spot on the S9. Absolutely spot on. So, doing the tune-up has corrected that. And it's the SM for signal meter. Right, we'll get that turned off. Just turn the power supply because I'm likely to short those out as I do that. Put the lids back on. 16 ohm square speakers, not replaceable. Don't lose one, don't break one. So I'm going to put some of the screws back loosely so we can adjust the cabinet fit. So this is a really nice example. I'm not just talking about its outward appearance, but technically this works a lot better than most. So we're going to do our on the air test with our replacement mic. When we go to the base station at the end, we'll put the factory original mic on as well, because my chances are it's a bit too bassy. And at the time there were people modifying these sets to make them less bassy on transmit. Well, you know, don't modify the set, modify the put a different mic to it. In fact, I'll unplug the PA speaker, we'll unplug the test instrument speaker, because now we're going to drop our screwdriver on the floor and switch the test gear off and plug it into the roof aerial. And we'll see what kind of bad buddies are on. We're 35 miles from Nottingham, 28 miles from Lincoln, something like that. I'll just unplug that to make it easier to fit the other two screws. The other two screws I have managed not to lose. I want to do another of those 3 amp power supplies of the band Taiwanese type, to see if we can do a little tiny modification during its overhaul to actually let them really do 3 amps, because they do about 2.6 before they start current limiting. Not that you need that kind of power, but with some of the modern multi-norms taking 2.5 amps, if the power supplies are bombing out about 2.6, it's not ideal. Right. We've probably got about 4 or 5 of company-owned ones of these, or the audio lines, and in a very, very sorry state when compared to this. So someone's really looked after it. Good. Power supply back on. One and a Roger. Oh, Roger on that, good buddy. I'm a Tancaster.
Yeah, Roger breaker.
Well, the cue there was for him to say where he was roughly, but I'm not going to start inquiring. We've actually got a Roger. Yeah, right. Yeah, like, oh, so am I, or I'm 2 miles down the road from you, or what? But no, it didn't work, did it? Still getting foreign interference, which shouldn't be here. There we go. Well, that's lovely. I'll get our bench dog out to prop it up, and we'll do an on-the-air test when Mr. Chippy's available. There are Uniden 200 from 1981, working an absolute treat. Thanks for watching.